Hello, my name is Mickey Swisher, and I'm a faculty member in the Department of Family, Youth, and Community Sciences at the University of Florida. I'm representing a team of researchers today that include colleagues from Florida A&M University as well as North Carolina State University. The topic today that I want to discuss is the idea of farmer-driven research design to develop more adoptable recommendations. So I see this as related to the global food economy that has developed. There's been a revolution in eating, as I call it, which says, you know, where does milk come from? And mom and dad tell you what it comes from the supermarket. It's a joke, I think, but it might be true. But it's also created a revolution in farming. The advanced breeding techniques are an example. I'm really fascinated by the generation of new farmers that's growing up around cities, urban folks starting farms and doing okay at it, making a living at it. So there have been a lot of changes, but as we know, innovation creates opportunities and it also introduces new threats. So today, I think sometimes we all feel that the threats just come at us faster and faster. Economic threats, social threats, biophysical threats in agriculture, cost of technology, agricultural land loss due to urban expansion, and pests and diseases coming at us. There's one study in 2016 done that showed of 1,300 invasive pests around the world, pests and pathogens. The biggest donors of those were the United States and China, and that's not because there's something bad about us. That's because we trade a lot and we're big trade hubs and we trade everything whether we meant to or not. So these changes are really rapid and far-reaching. We've seen that with things like citrus greening in Florida, from one county to every, 4 I guess it was counties, to all the production counties in 10 years. So what we're trying to do here is to find a way to speed up this discovery process because it is a lengthy one, while producing outcomes that are good biologically and good economically, but also make it easy for farmers to adopt them, make them fit the farmer systems very well. To do this, we look at two kinds of knowledge that we are trying to combine: scientific knowledge and experiential knowledge. We in science, we use scientific knowledge, and we all know that drill. We test hypotheses, we try to limit non-experimental variance, and we throw out things that fail, that do not work, and ultimately we end up with good, viable, valid, reliable results. Experiential knowledge is distinct. It relies on long, in-depth observation of complex systems across the full range of conditions. It is the unanticipated events that produce very rapid learning and require rapid adaptation, of course. And eventually, over time, farmers amass, and other professionals who engage in these kinds of observations, amass knowledge over time. They can understand how and why things happen. Our principles are four for what we do: empowerment. So farmers are fully involved in every step of the research, starting with research design, all the way through analysis and recommending extension programs and such. Transparency, everybody's got to know what's up and be able to speak up if they don't want to do it. Mutual respect, none of this, your kind of knowledge is bad and mine is good. Everybody valued equally with regard to knowledge, ideals, and experience. And both scientists and farmers have to be responsible to the team as a whole, otherwise it won't work. There are three components, and I'm going to talk about each of these in a little bit of detail. Grower assessments. The idea behind these is that we're going to improve the quality of outputs from this project. So what we get from this process are group consensus recommendations. And how we do that is that we have 5 or 8 growers usually representing a broad range of experience with the system of interest. They go out, they directly observe our plots in the field. We don't tell them what's in there, in the plots. They're just numbers. They're just observing. You see, she has a clipboard and papers in her hand. They discuss their observations then and identify the best and the worst treatments. And ultimately, at the end of the session, they give us 3 recommendations. One for something to eliminate, one for something that could be added, and one for something that we really got to keep. Farmer think tanks are similar to the advisory council, but differ in some ways. They provide us strategic recommendations. So we're asking them to look at the totality of a research program over a period of time. We meet about twice a year. They assess our findings. We present our findings to them, all of them, in short video clips, sort of like what we're doing. And they serve, if possible, for the entire project, certainly for 2 or 3 years. So we asked them to discuss and analyze their finding in a facilitated group discussion, and they make more overall kinds of recommendations, especially when you get down toward the end of a project where you've got a significant body of knowledge accumulated. They help us understand what the next steps in research ought to be. And the third piece are the farmer-designed on-farm trials. The idea there is to subject treatments that are promising and that farmers pick that they want to test on their farms to a wide range of variants, to all of the variants out there. And a lot of the variants is usually farmer practice, more even often than biophysical kinds of things. So they put the treatments on farms. We develop a data collection plan with them, but they collect the data. And then all of us, the farmers doing these trials, the think tank people, and the scientists get together and discuss all of those outputs and figure out how to use it. So I'm going to give some examples here. We've eliminated, in this project, that we've eliminated potential solutions and we've added some. So here's an example of elimination. We had a cultivar that the scientists, sort of thought it was a standard for comparison in trials. Turned out growers said, no, we like it because it's heat tolerant, but it's an insurance factor sort of for us. So, because it gets too hot in Florida early on for strawberries. So we said, okay, well, that's interesting. So you're saying people are going to keep planting it for that reason. We shouldn't then treat it as a grower standard. That's not how you're perceiving it. And eliminating that saved us time and money we could devote elsewhere. Addition, growers said, look, we do a lot of cover crop work on this. They said, we'd like to see you test a treatment that is more than one cover crop, a mix of cover crops in a single treatment. And they thought that would give better biomass and coverage. And they said, though, can't lose the focus on nematodes. So we did that. We put together that treatment, and it has turned out to be an excellent treatment. So they were right about that. And we've also learned to practice flexibility. We gave up on high tunnel research for strawberry production here in Central Florida, where I'm at it, and around Gainesville. It's just not, the focus is just not the interest of farmers around here. And this is the area where we work. So it's like, oh, okay, well, So we gave up on that, but, oops, let me flip back there. But that research continued at Florida A&M University and also at NCAT at North Carolina A&T. And it's really evolved to be very interesting. They've added some new alternatives to the arsenal, so to speak. So they've really explored low tunnels and low-cost high tunnels and added these as alternatives. So it gives the cold protection and the season extension. And they're a lot cheaper to construct. Growers can construct them themselves, so that's really an advantage. And they're really hypothesizing that even low tunnels could perhaps provide similar results to what commercially built high tunnels do at a much lower cost, of course, than those are. So we're at the point in this project where we're working on our agenda for the future. We're meeting shortly here with our think tank. The growers on our team, though, have said 3 things to us over and over. One of them is they really want more comprehensive sort of whole enterprise or even whole farm kinds of economic analyses associated with our research, because they say over and over, if I change one thing, inevitably it means I got to change a lot of other things. So I need to know the totality. We all think, I think, that we need to, excuse me, I keep flipping slides. We need to improve the on-farm research process to demand less time and effort from the farmer, and at the same time generate data that are more useful for scientists on the team. That's what we are struggling with right now. I suspect we're going to go into a mixed mode of data collection, but we're just starting to explore that now. And a third thing they have said over and over again is that pest management, including nematodes, must remain a high priority for future research for the foreseeable future. When we're talking about organic strawberry production systems, I would say that's probably a generality to be true. So that's, what have we learned? Well, we have learned that farmer-driven adaptive research does indeed save time and money. It particularly helps you move away from things that farmers look at and just say, not going to happen. So that's a good thing. There's some caveats, though. One of them is that scientists who participate in this kind of research have to be willing to take some professional risk. because people are going to ask you to change treatments or to add some kind of data collection. That's what goes on. That's what farmers come up with. That's what we're asking them to do. So what you really have to do is be willing to take some professional risk and do that. Because if you don't, you can't just say, no, I won't do it. That won't work. That destroys team confidence. Farmers also need to invest fully in the scientific discovery process. They need to understand scientists' needs just like we need to understand theirs. And they need to be willing to engage in some lengthy planning and analytic processes. And I think that we really attract people who are interested in the science as well as the practice of agricultural production. And I must say, I think there are a lot of farmers who meet that definition, and it's really enjoyable to work with them. So I'm going to end here. Our team out planting strawberries. We have learned that this takes time, effort, patience, and understanding. Those are definitely 4 ingredients in this mix that you just must have. I want to thank you for your time, effort, patience, and understanding today. Thank you for working with us today. Have a good day. Goodbye.